Alright, well hello physical science students. Welcome to this video, which is meant to kind of debrief the graphs and tracks activity you did, the second one, where you were actually dealing with the ball rolling down a ramp, or rolling up a ramp, whatever. And you should have seen some interesting graphs being created. And so far we've been looking at objects that have been moving with a constant velocity, but now understand if that ball is rolling down the ramp, it's actually accelerating. It's going to move faster and faster and faster. So you should have started to see position versus time graphs with curves starting to be created. Now we need to understand what these curves are actually telling us. So first one here, remember that the slope of a position versus time graph, that tells us what the velocity of that object is. Okay, that's super important. So if I were to look at the slope of this position versus time graph, I could even draw little tiny lines all the way along here. And you can see that you have positive slopes, meaning that this thing is moving in the positive direction. But now, is this object speeding up or slowing down? Well, take a look at these little lines that I drew along here. These lines are getting steeper and steeper and steeper, meaning that that object is moving faster and faster and faster, right? Like if you just saw a position versus time graph that had a line that looked like this and then a line that looked like this, well, we would say that this one's moving faster because it has a steeper slope. Same kind of deal is going on here. Okay, so because our slopes are getting steeper and steeper and steeper, we know that this object is speeding up. And because these slopes are positive, we know that it's speeding up in the positive direction. Now, the next piece that we really need to figure out here is, how do we go from a position versus time graph and create a velocity versus time graph and create an acceleration versus time graph? So again, this object is starting out moving slowly and it's getting faster and faster and faster in that positive direction. So on a velocity versus time graph, where your x-axis is 0, we would start at 0 and show a line that goes like this. This line is showing us that this object is steadily increasing its velocity, meaning that it has acceleration. Okay, so now how do we go from a velocity versus time graph to an acceleration versus time graph? Well, a velocity versus time graph, the slope of this tells us what the acceleration is. So you can see here that I have a constant positive slope, meaning that I have a constant positive acceleration. So what that's going to look like then, it is going to look just like this. Okay? All right, now moving on to number 2, starting with our position versus time graph. And you should have seen this shape being created with one of those scenarios you set up in graphs and tracks. So again, I'm going to draw my little lines along here. And now what's interesting is that you're seeing that we have negative slopes, but these slopes are getting steeper and steeper and steeper, meaning that this object is moving in the negative direction, but it's also speeding up. So what does that look like on our velocity versus time graph? Again, where our x-axis is 0 meters per second, not moving. Our velocity versus time graph, if we're speeding up in the negative direction, would look like this. Okay, once again, we're seeing that this line is moving away from that x-axis, meaning that this object has to be speeding up in the negative direction. Now the acceleration versus time graph, again, the slope of a velocity versus time graph tells us what the acceleration is. So we see a constant negative slope here. That means that our acceleration versus time graph would have to look like this. All right, now I want you to pause the video and I want to see if you can do scenarios 3 and 4 here. So you're given a position versus time graph for each. I want to see if you can create the velocity versus time graph and the acceleration versus time graph for each. All right, so let's check our work here really quick. So if you take a look at your position versus time graph with this one, again, we're seeing positive slopes, but what's happening to those slopes? They're getting shallower and shallower and shallower, closer to zero. That means that we're moving in the positive direction because we see these positive slopes, but we're actually slowing down. So what does that look like on this velocity versus time graph then? That is going to look something like this. So you can see here that we start at some velocity, but as time goes on, that velocity moves closer and closer to zero. All right, now the acceleration versus time graph. Again, slope of velocity versus time graph tells us the acceleration. So I have a negative constant slope here, meaning that my acceleration versus time graph should look like this. All right, and then the last one here. We have negative slopes, and those negative slopes are getting shallower and shallower and shallower, meaning that we are moving in the negative direction but slowing down. So what is that going to look like on our velocity versus time graph? Just like that. Okay, now the acceleration versus time graph, we're seeing a positive constant slope. So that means our acceleration versus time graph would look like this. Okay, so a few key points here. On your position versus time graphs, when you see these curved shapes, you know that you have acceleration. You can determine what type of acceleration by drawing these little lines along here to help you out, so you can see which direction the slope is, and you can see how the slopes are changing. Okay, in this case, we have negative slopes. They're getting steeper and steeper and steeper, meaning that we are speeding up in the negative direction, meaning we would have negative acceleration. Now, one little trick for you. If you're ever given a velocity versus time graph, if that line on your velocity versus time graph is going away from the x-axis, that means you're speeding up, okay? If it's going towards the x-axis, that means you are slowing down. So you can see in both of these cases, 3 and 4, your velocity versus time graph is getting closer to the x-axis, meaning that you are slowing down. In 1 and 2, both of your graphs were going away from the x-axis, meaning that you were speeding up. All right, just to apply this a little bit more, these ideas of being able to determine an object's motion from these position versus time graphs. What I have here is I have a kind of a complex position versus time graph. You can see that we have 3 very distinct types of motion here. So, looking at this first section of motion, we see this curved shape. We have to decide what this object's motion is actually like. So again, I'm going to come along here, I'm going to draw those little lines. We're seeing that they're positive, so we have positive slopes, and they're getting steeper and steeper and steeper, meaning that this object is speeding up in the positive direction, meaning that it has positive acceleration. Now in this next part here, we see a horizontal line. What would a horizontal line mean on a position versus time graph? That means that this object is not moving. As time is going on, this object is staying in the same position. Okay? And then this last piece, this one should be pretty easy. You're seeing this constant slope, and it's positive. This means we're moving at a constant velocity in the positive direction. So, I hope this video was helpful. Hopefully it kind of debriefed some of the things you saw in that graphs and tracks activity. If you have any questions, or need me to clear something up, please do not hesitate to ask.